In this lesson, you will learn how to multiply radicals. Let's take a look at some notes and examples that better explain this concept. This first problem says radical 5 times radical 5. When you're multiplying radicals, you can simply multiply the numbers under the radical symbols together and then simplify from there. So let's multiply 5 times 5, giving us 25 under the radical symbol. Now we will simplify radical 25, and the answer is just 5. The second example is radical 2 times radical 32. Once again, we will multiply the numbers under the radical symbol to combine them together. This would give us radical 64. Because 64 is a perfect square, we can take the square root, leaving us with an answer of 8. In this next problem, we will begin the same way as we did the last two problems. We will combine the two radicals together by multiplying the numbers under the radical, giving us radical 24. But this time, 24 is not a perfect square. So in a previous lesson, you learned how to simplify radicals that were non-perfect squares using factor trees. So we're going to go ahead and do that. We're going to take the 24 and create a factor tree using prime numbers. So we can break the 24 down into 2 times 12, and we'll circle any numbers that are prime. We can then break the 12 down into 2 and 6, and the 6 down into 2 and 3, until all of the numbers are prime. So what we have is 2 times 2 times 2 times 3. Now from here you underline any pair of numbers. So we have the 2 and the 2. The other 2 and 3 that are not the same number are going to be multiplied together and will remain under the radical. So this one is square root of 4. So let's go back under the square root of 24 and put square root of 4 times the square root of 6, because that's what the square root of 24 breaks down into. Now, because 4 is a perfect square, we can actually take its square root, changing it to 2, but we will leave the 6 under the radical. So our answer for this problem is 2 radical 6. Our next problem will be similar to the last. We can first multiply the numbers under the radical to combine them together. And 12 times 6 is 72. Again, because 72 is not a perfect square, we're going to need to break it down using a factor tree. So starting with 2, 2 times 36 is 72. We will circle our prime number and then break down the 36. We then have 2 times 18, and then we'll break the 18 down into 2 times 9, and then the 9 down into 3 times 3. So that would give us 3 2s and 2 3s. If we underline our pairs, we then have radical 4, radical 2, and radical 9. So bringing that back up, we've got radical 4, radical 2, and radical 9. We would then simplify our perfect squares, which would be 4 and 9. And those would go on the outside of the radical symbol. And if we multiply those together, we get 6. The radical 2, which is not a perfect square, will simply drop down into the answer. So our final answer would be 6 radical 2. In this problem, we're going to multiply 3 radicals together. So 2 times 6 times 12. 2 times 6 times 12 is 144. And 144 is actually a perfect square, so this one's pretty easy because it simply equals 12. Notice in this next problem, you have a number in front of each radical. So those numbers are already outside of the radical. So what we're going to do is we're going to multiply the numbers outside the radical together And then we're going to multiply the numbers under the radical together. Okay, so outside to outside, inside to inside. Now we need to break down the 12. So using a factor tree, we would get 2 and 6, and then 2 and 3. So we have a 2, a 2, and a 3 for our prime numbers. We'll underline the pair and multiply those together, and drop down anything that's not a pair. So the 12 breaks down into radical 4 times radical 3. The 12 that we have on the outside will just continue to drop down. Dropping this 12 down one more time, we then take the square root of 4, which is 2, and drop down radical 3. And lastly, we'll multiply our outside numbers to get 24 and drop down our radical 3. So the final answer is 24 radical 3. Similarly, in this problem, we can multiply the numbers outside and get 4. Now, the numbers under the radical in this particular problem are quite large, 18 and 12. So you have two choices. You can either multiply them together and then break their product down, which might be a very large number, or you could do factor trees for them individually and then combine their prime numbers together. So I'm going to go ahead and do that, and we'll see what we get. If I break the 18 down, I get 2 and 9 and 3 and 3. So far, the prime numbers are 2, 3, and 3. If I break the 12 down, I get 2 and 6, and then 2 and 3. So I'm going to group all my 2's together. So I'll group these all together. So the two 2's I have here and here, I'll put in front. And then this 3, I'll stick at the end. So now I just underline the pairs, then I create my radicals. I've got radical 4. The other underlined one is radical 9. And then my 2 that are not underlined, I can multiply together to form a third radical. So in other words, what I have right now, besides the 4 on the outside, is I have a radical 4, a radical 9, and a radical 6. The 4 drops down, radical 4 becomes a 2, and radical 9 becomes a 3. Radical 6 we will just drop down. Then we can multiply our 3 outside numbers. So 4 times 2 is 8, and 8 times 3 is 24. And then we'll drop down radical 6. So the final answer is 24 radical 6. This next problem is read 3 radical 2 quantity squared. That means the entire thing is squared or multiplied by itself. So you'd first want to write it out, 3 radical 2 multiplied by itself, 3 radical 2. So as we've done in previous problems, we're going to multiply our outside numbers and then multiply our inside numbers. This time the radical is a perfect square, so we'll drop down our outside number and then change radical 4 into 2. From them we just multiply those two together to get a final answer of 18. The last problem, which is similar to the previous one, or this problem is similar to the previous one. Again, 5 radical 3 squared just means that 5 radical 3 is going to be multiplied by itself. So multiply the outside numbers and multiply the inside numbers. Then take the square root of 9, which is a perfect square, and drop down the 25. And then to finish, we need to multiply 25 times 3 to get a final answer of 75. And this completes the lesson on multiplying radicals.